I wanted to welcome you to this talk, where we will show some interesting points for you, Gloo Edge users. My name is Antonio Berben, and my colleague Jesus Munoz and I are field engineers in Solo. Our job consists of being in touch with customers and the community on a daily basis, understand their complexities, their struggles, and how we can help them to meet their goals. Making the story short, we help on the path. Based on that experience and the discussions with the community, we have collected some interesting points that we wanted to share with you during the next 45 minutes. We will talk about the Envoy filter, how the configuration is segregated to accommodate it to your team roles, different ways of how to implement security, profile and Envoy admin interfaces, how to optimize your configuration for a production environment. The topics have been selected for an audience with some experience in Gloo Edge. However, if you are new to Gloo Edge, don't worry, the concepts are quite simple and you might find them interesting. Then later, you can join one of our workshops we do regularly. You can find them in our website. At the end of the session, there will be time to answer your questions. Now, let me hand over Jesus, who is going to talk about the Envoy filter flow. Let's have some fun.
Hello, in this part, I will explain how the filter flow works, how the different filters work together and interact with each other. First, before going into details, an overview. In the Gloo Edge, there is the control plane that is reading the CRTs, the configuration, and is producing Envoy configuration. Envoy configuration that obviously applies to Envoy proxy, and that Envoy proxy is also having additional filters that are provided and implemented by Solo and compiled into the Envoy proxy. So, how an Envoy proxy config looks like? So basically, we can focus in three parts. The first part is the listeners. The listeners are sockets that are used to listen for traffic. And then clusters that are destinations, upstream, backends. And then in the middle, there is a filter chain that is attached to a listener. And a filter chain can have different filters. One of them is the HTTP connection manager, that is a network filter that allows you to configure the routing and configure many other operations that we will see now. So these three parts, the listener, the destination, that is the cluster, and the routing, the filter chain, can be described in the Gloo Edge with the three different CRDs. The first CRD is the gateway. The gateway defines a listener. The upstream CRD defines a destination, a cluster in Envoy, and a virtual service is used to describe the filter chain. You can define routes there, different matches, and then routing to different destinations and apply different operations or transformations that we will see now in more detail. This is more or less how the filter chain looks like. So a client makes a request, then goes to the filter chain, and then ends in an upstream, in a destination. And in the middle, we are going to start with the one in the middle, that is external auth, that is a filter that delegates into an external server. In the next talk, I will explain the external auth in more details. And then, in this filter, you can do many things. And then the last filter in the chain is the router filter. The router filter, obviously, forward the request to the upstream, but everything that is related to the upstream, like retries, timeouts, or adding or removing headers from the request or response, this kind of thing can be also implemented in the router filter. In the router filter, you can do many things. There are filters that can be applied before or after the external auth. The first one is the JOT filter that is used to validate a JOT signature or to extract a claim from the JOT and to put that claim into a new header, for example. The transformation filter is other one that you can use before or after the external auth. And in this transformation, this is a very popular one that is used to make changes to transform using templates, the body or the headers, or both the body and the headers. If you have JSON, you can read the JSON directly or this kind of thing. There is also something that is clear root cache that I will explain now. When the request reach to the HTTP connection manager, so it's in the filter chain, the routing decision is made. So based on headers and other things, the decision of the destination is already done at the beginning. But in the middle, using filters, you can introduce or remove or manipulate different headers. So at some point, you can decide with this clear root cache to evaluate again the routing decision. That is actually a very useful feature. And then the rate limiting. The rate limiting is a filter that can be applied before and after. And the rate limiting uses a server, an external server, to provide the functionality. And we use for the rate limiting something that is called the set style API. The set style API is a very easy way to describe complex scenarios. So I really, this is a really interesting topic to dig deeper. But I can do it now. Before the external auth, there are several filters, like all these ones that make sense. For example, the WAF, the Web Authentication Firewall, or the DLP, the Data Loss Prevention, or CORS, or these others. And there is also one that is at the beginning that is a direct response. The direct response, as the name suggests, is a way that directly answer with a 200 or with the code that you want, or with a redirection, or this kind of thing. And that is evaluated at the very beginning of the route selection and in the first stage, and that will not change with other filters. The direct response is giving the response and not executing the rest of the filter chain. And well, for the filters that you apply, for example, you can define the filter in Gloo in two different places. You can define it in the virtual service level, or you can define the filter at the root level. If you define a filter for a particular route only, that will take precedence that the settings that is defined at the virtual service level. And to finalize, this is the full picture of how all the filter chain looks like. And there are filters that only make sense after the external auth. For example, the ARBAC filter, or these other ones, the ARBAC filter in this case needs the JOT filter to have information about the claims. And an additional tip that you can define paths in the auth config. Auth config will define the behavior in the external auth, and this path will be handled by the external of server, not by this filter chain. But the filters that come before, like a course, will execute it anyway.
Thank you, Jesus. Now let's talk about delegation and root tables. But before that, let's just mention something about DevOps. The goal of DevOps is to increase organizations' ability to deliver applications and services. It is described as good practices, sometimes as a journey. One of its practices is to have end-to-end teams. That means that in one team, we have different roles to fully deliver and operate the service. The reality is that not every company can make that change. It is quite common to find different teams for developers, development teams, and for operators, for example, platform teams. Now let's see how we cover all this with Gloo Edge. If you are familiar with Gloo Edge, you will recognize following resources. Those are key points. In a fully DevOps environment, you would not need anything else. The roles in your team will cover end-to-end. However, as we can see here, in the case that you have different setup, you've got different teams, we need to create an abstraction layer to link the two worlds, devs and ops. This object is called root table, and it is designed to allow you the segregation that we are talking about, as well as to increase the dynamism in the configurations. You will see this later. Now let's apply those concepts in a small demo. Here we are going to simulate the operability and configuration of two applications, app1, which is at the end an HTTP bean server, and app2, which is yet another HTTP bean application. Our environment is going to look like this. We are going to first deploy an application under team 1, another application under team 2, and finally, a virtual service to access those applications. This virtual service is for the case of a full end-to-end team where they own all the resources. They can deploy whenever they need. So let's create the namespaces. Team 1, team 2, and then the platform team. Now the application 1, the application 2, and the virtual, we call it the first example of the virtual service. More or less so far, we didn't segregate anything. Everything is under one namespace. Let's try to access the applications. And for the sake of this demo, we're going to see that we inject a header when we access to application 1. And when we access application 2, we've got different header. So we can differentiate them. Now, what we're going to do is to split this virtual service into two root tables, and we're going to make the delegation. How do we do that? It's as simple as now our virtual service is going to call delegation to the two different resources deployed in application 1 and in application 2. So let's go for it. Deploy this one. Now we go for the A and for the B. And if we access again the applications, we will see that now we have changed in order for the demo to see the effect. What we have done, it's that now the header is changed to inject delegated. The root table is going to inject this header to notice that this is going through the root table definition. As well in the team 2 with the delegation. And we can see here that those two different applications have different header. As we can see here, the root table application 2 belongs to the namespace 2, and the root table for application 1, it's under team 1. That is how, at the end, we get what we need. Now we've got that all the resources related to team 1, it's handled by team 1. All the resources related to team 2 is handled by team 2, and all of them, they are in different namespace. Now let's hand over Jesus, who's going to talk about compose your own security workflow.
In this part, I will explain how to you can compose your own security workflow. Gloo Edge comes with different filters that provide different features, and these features, as you are already aware, are transformation, web application firewall, DLP, connection with lambdas, and all this kind of thing. But there are two features that are the rate limit and the external auth that also needs an additional server, and this server is provided by Gloo. So there is a rate limit server, and there is the exot server. The exot server comes in its own with the many features. So you can configure the exot server in Gloo to provide basic authentication or API keys or OPA or this kind of thing. But this is not only what the exot server does. There is also the possibility to connect to that server your own infrastructure, your own servers. So any OpenID provider or custom authorization service or LDAP or all this kind of thing, combined with the features that are implemented in the exot server. How can I do this in a real world scenario? So you can compose your own flow. To compose your own flow, you need to use the authconfig CRD. And in the authconfig CRD, you have an array of steps. So in this case, the first step is an OAuth authentication with a Google account, and then you get a token. You get a token for the first step. In the second step, using that token, because you can share information between steps, you can read the claims of that token, and using your own server, you can extend the information with your own logic. You can create a new token with the extended information of your company. And after that, using that new information, you can implement an OPA policy. OPA is an open policy agent, and it's Gloo Edge supports OPA out of the box. You don't have to provide anything else, just the rules, just the regular rules. And that in this case can be, I want the email that is decode from the job token to end with solo, for example. And that will compose very easily a 3-step workflow that is custom. Additionally, you can also use external or more authorization servers, and these servers can have a custom implementation, a different implementation in each one, and you can attach or use those servers for different routes. So in the root corp, you can use one server. In the root of 10 and 1, you can use another server, as many as you want, and also combine with the exot server. So you can say the default is the exot server, and for particular routes, I use particular authorization servers. That gives us a lot of flexibility, for example, when we want to implement a tenant-based scenario.
Thank you, Jesus. Now we are going to talk about profiling an Envoy admin interface. Being a Gloo Edge user, you might know that it offers a high-level API to configure your proxies. Those proxies are the data plane and are built using Envoy. That is the foundation from where we create the control plane and all the related components Gloo Edge offers. The picture then, it is that you are just configuring. To give an example, one of the Gloo Edge capabilities is to transform the body of the payload. This means that the content body is going to be parsed, transformed, and then the request will be routed to the upstream you want to expose. In the case of a huge payload, this can mean a huge amount of CPU and memory consumption due to an stress of the system. In that scenario, how could you know the reason of the high CPU or memory usage? In order to have visibility on what's happening, Envoy offers to the user some tools. From that approach, Gloo Edge has come out with similar set of tools to help on debugging and understanding what is happening in the entire system, as such as low level, like the process itself. Let's have a look to how we can get this information from our system. Let's have a look how the Envoy dashboard looks like. In order to do that, we're going to expose the gateway proxy on port 19,000, and this is what we see. From here, we can get a lot of information. We're going to be focused first the statistics for Prometheus, so you can have your own Prometheus scrapping these metrics. You can also change the log level, as you can see here, the log level of different components, which are loggers within the application. Now they are all info. Let's change them to debug. Now they are all debugged. Not just this, you can even change only part of them. As for example, let's be focused only on upstream. Let's revert it. We make all info again. And now let's just point, because we want to just debug the upstream. We don't need to overload the log traces, because then we got lost when we are debugging. So what we do, it's just the upstream. As you can see here, upstream is debugged. And if we go to see the log traces, we can see now that debug and it's upstream. So we can be focused on what we want to debug. Another interesting thing from the dashboard is the confidump. Confidump is the representation that Gloo sends to the different proxies. As you can see, it's really difficult to debug in here and to find what we want to see. To solve this problem, one of our colleagues, Denny, has created a very easy to use UI where we just need to download the dump and upload it to this UI. Here is publicly accessible, so you can usually use it at any time. And here it was the example that we used in the previous demo, where we created two applications, app1, and if we remove the filter, the app2, if you remember. So now it's quite easy to understand what is happening in this configuration. That is, to be honest, when we debug, we go directly to this file, or this is the primary data that we ask to our customers to figure out what is happening in the system. In the same way, Gloo has its own dashboard to help on debugging or operating. So let's stop this detailing, and let's just open the Gloo. In Gloo, we expose it under 1991, and this is what we see. It's much simpler because we don't need to expose much things. Important things here, the metrics, once again, we're gonna have a Prometheus server scraping these metrics to then be exposed in a Grafana dashboard, and the profiler. The profiler is quite interesting because, as we mentioned at the very beginning of this talk, there are some scenarios where we have a huge CPU or memory consumption, but we don't know why is the reason. If we see maybe an example of representation of a profile is the flame graph. The flame graph shows all the stack within the application which is being executed in a period of time in that profile. Intention with this is like, we're gonna spot quickly the CPU or memory that is being used at that time when this process runs, this process or this function. There is one way to download it and then verify it locally, but here, what we're gonna use is a tool which is called Pyroscope, and it's following the same approach like Prometheus does. Offers you the possibility to configure and scraping and polling, not pushing, but polling mechanism. So you just deploy with a Helm chart, like I did previously, and the applications you want to scrap, you need to give them notations, special annotations, in order to Pyroscope to start scraping. You're going to define the port, exactly like, more or less, if you're familiar with Prometheus, this is the way that Prometheus does. As you can see here, we can, Prometheus, by default, Gloo is configured like that. So now we also configure to have these annotations, and Pyroscope is able to scrape it. And also it comes with an interesting Grafana dashboard and panel. You can configure here, and right now, this is what is happening in my system. This is defined for the memory consumption. We can see here the process, the stack in the sorry, the process in the stack which is being executed and which is the consumption that is happening. So if we can go maybe to edit, we can see here that is just for the memory, but also for the CPU. We can create another for the CPU. Applied, and this is what is happening. So we can see the CPU consumption easily within the process. So this helps us a lot to debug what is happening. Now let's hand over Jesus, who's going to talk about tips for production-ready control plane.
Hello. In this part, we'll be showing some tips to deploy Gloo in production. So we have a Gloo system that is now just installed, and I will be first showing a root, a good root that doesn't exist yet. So we'll be seeing only 500 in this case, right? The line with 50 requests per second, all of them paid. First thing that we are going to try is to apply an invalid virtual service, and with that CRD that I have made up. So the first thing that we need to make is to see that the Gloo is going to reject this configuration. So let's now apply a valid, partially valid virtual service that have two roots defined. The good root, that is the one being monitored here, and a bad route with a destination that doesn't exist. So let's apply this partially valid configuration, and then nothing happens. Nothing happens because the good route, this one, doesn't work because the configuration is accepted or rejected as a whole. The first change that we are going to make is to allow partial configuration. So for that, we will define in the Helm chart this invalid config policy with the custom message that you can choose, a custom code, usually is 404, and this replace invalid routes true. So after this is applied, then we see that the good route start working. So you can expect this to work, and the route that is not well defined give us the custom message. That's the first thing. Let's do something more interesting. For example, we will apply several changes. Apart from the one that we did, we will define proofs, health proofs, and graceful shutdown for the gateway proxies. And then some affinity, some node affinity. In this case, the nodes should be labeled with this label. I don't have any node of this kind, so let me label them. And we will see that after I label them, the container is created. And then the new gateway proxy with the new proofs is started, and the old one is terminated. But you observe that there was a minimal service interruption here. This red line have a small peak. So let's change that. Well, that happened because the old server didn't have this these proofs. So what we are going to do now is to restart the gateway proxy. So a new one is created and the old one is terminated. And this time, as you have the proofs and the graceful shutdown, you don't see any interruption in the service. Let's do something different, because these proxies are configured from the Gloo pod. The Gloo pod is the one within the configuration and producing the snapshots. So what happens if the Gloo pod died? Nothing happens, because the proxies are well configured and they still work with the latest stable snapshot that they have. But now, when the control plane is down, let's force a restart in the gateway proxy. So, for example, this can be a restart or an escalation, or maybe this gateway proxy breaks while the Gloo pod, the control plane, is not available. What happened in that situation? In that situation, what happened is the gateway proxy starts, but is asking for the configuration and is not able to get any configuration, any snapshot. And that ends in a gateway proxy that is not configured. So when that happened, that is you start seeing all the requests be failing again because there is no configuration in this proxy. Let's fix that with something that is called the XDS relay. This is a new chart that we can install, and that will allow the control plane to be scaled. You can, as you can see, by default is coming with the three replicas, and then this will be used to store the stable snapshots, and the proxy will be taking these snapshots from here. So how to do that? Very easily, just defining the same thing that we did before and defining the service address of the XDS relay and the service port. This change that we will apply to the health chart. And then from now, the gateway proxies will get the configuration from the XDS relay. If I now restart the gateway proxy will be taking the configuration from the latest stable snapshot. It works. But it's working now. The other one is terminating. But this is easy because the Gloo pod is also running. So you can say, oh, no, it's taking from the Gloo pod. Let's destroy the Gloo pod. So the control plane is gone. And now restart. Now restart again. Let's let it die. Yeah. And now restart the gateway proxy. And let's see if the new proxy can get its configuration from the relay servers instead of the Gloo proxy. It can, and you don't see any interruption in the service. Now you can scale the Gloo pod again, and the change is until you scale the Gloo pod again, you cannot make changes to the configuration. So everything will be running with the latest stable configuration, but if you apply changes in the configuration, they won't be propagated until the Gloo, that is the one doing the translation, the Gloo pod is alive again. But as you have seen, this process is decoupled from the data plane, that with this configuration is not breaking, even if there are some failures in the components. Enjoy. This is everything. Enjoy the rest of SoloCon. Bye.